All right. Hello, everybody. Welcome back. ENGR 248, SolidWorks. Week 5, we're going to start into assemblies. So the good news is we have to continue to make parts. And you all are making parts really well. So the rotors look fantastic. Nice job on that. The drawings look good. I am not going to spend a lot of time critiquing drawings because I didn't really go over graphics in this class. Some of you have had me for graphics and know how to produce a drawing. Others maybe have never had graphics. So, the whole orthographic projection and the proper dimensioning and all that may be foreign to you. So I'm not going to be very critical on that. You can get in and make a drawing if you need to. That's the important part of this class. So the next thing is for us to work towards assemblies and getting good at those. And that's going to be working towards your final project. So I have a final project pulled up that I'm going to show you of a student in this class in the past. Of course, I'm going to show you a really good one, hoping that you aim high for your final project. But you should start thinking about what you might want to model. So I will put up the requirements for the project and the constraints. Usually it says something like you must have 5 unique parts. There must be some kind of motion. Of the 5 unique parts, there should be some difficult modeling involved. You're going to assemble it. You're going to make it move because it does have to have some motion. But for example, like the motion could be this spinning. Okay, so it doesn't have to have a motor or an engine or anything. It just has to have some kind of motion. The other kind of motion could be, a box that opens and closes. That's motion, right? So this is an assembly of many things, some of which would be very, very difficult to model. So you got to choose wisely, but do start to think about it because in about a week or two, you're going to have to propose your project to me. And I have had so many over the years that are fantastic, that are just fun to show off. And I pulled one up today. So let's look at it. I'm going to make myself a little smaller here. Scoot me away. Yeah. So this individual modeled a chair and phenomenal job, right? A lot of parts, a lot of very difficult parts, but these parts, you can see them all over here. These are all the parts in this assembly. So remember, I said you got to have at least like 5 to 7. This individual has 20 plus parts probably in this assembly. But the motion for this one, when you slide it around, you can see that not only does it move up and down, but also the base spins, and these casters actually move. So as I move it, you can see the casters rolling around and also rotate. So yeah, super fun. Like, honestly, this is fantastic. Not all of us have this kind of time in our life to model something like this, but just this base probably would have been close to enough, and I think I remember when he proposed it, that he proposed the whole chair, and then I changed it and I said, why don't you do the base and maybe, the shafts and the bottom plate, this whole bottom plate area. And then if you get it all done and you're happy with it, you can add the chair on to kind of do more than you proposed. So you can do that. You can propose kind of in 2 levels. One, the base level, you're hoping to get this base area done type of thing. And then if that goes well, you'll continue to work on the chair and get as far as you can. So I'm not saying do a chair. I'm just saying that's how you can build your proposal. So what we got to do is we just got to get to making some assemblies, right? And trying to understand how to bring parts together. So that's what an assembly is basically a collection of parts. So we're going to first model our parts separately. So you can model the parts in an assembly, but that's just a little more complicated. So So I'm just gonna walk through basic assembly technique. Your exercise are very simple parts. So it's not really a, part challenge at all. I just want you to practice pulling them together into this assembly here. So here's your parts. Here it says create the 5 parts. That's because it's 1, 2, 3, 4, 5. But I also said create pins. So really you have 6 parts. So I want pins in all the areas that are pinned, like here, 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 and that'll be good practice for you. So I'm not gonna make all these parts. You actually will make these parts very quick, I'm sure. Make the parts separately. So make a part. You can leave that part open, but then start a new file and create a new part. So name them. You can name them these: connector 1, connector 2, blade, crank, and ground link, and then maybe pin for pins. But I did say in the assignment here, make the pin diameter 0.245. So it's really just practice in mating, which is what we do when we bring assembly parts together. So, all right, let me just give you a brief rundown on this. I'm going to make a couple of quick parts. So I'm just going to make, they're calling it a ground link. I'm just going to make a block, basically, that's going to kind of be the base. So I'll give it some dimensions. I'm not going off your drawing at all. I'm just doing my own thing here. I actually forgot what plane I just drew that on, so we'll just make it symmetrical just in case. I'll extrude it out, and then we'll go up 2 inches. So this is just going to be like a base thing, okay? So my base block, and I'm going to name it, and I'll just name it base. When you do this, you're going to want to create a folder. Whoops. Why am I losing it here? Okay, we're good. I'm going to go to my desktop. And I'm going to create a folder there. And I'm going to call it week 5. All right. You should do the same thing because we need to collect assemblies together. All the parts got to stay together and the assembly has to stay together. So create a folder and then save your base or your parts and pieces in that folder so they're all together. That's super important. I'm going to cut a hole in this side. I'm going to just pull down this mark here and then pull this mark over here and bring them together. Sometimes you have to be persistent with these. There it is. So that's the geometric center of this thing. And I'm just going to give it a 1/2 inch diameter. So your pins, I think, are 1/4, mine's a 1/2, right? And then I'm going to cut this. So still just making my one part. I'm going to cut all the way through and we're good. So that's my block, right? So hit save. It's saved. And I'll start a new file. So now I'm going to make a link and I'll make a pin. So I'll make 3 things in this little demonstration. And then I'm going to pull them together and show you how to mate. So I'm just going to head off and make a new part, right? So when you do this, you're going to want the lab open or you're going to want to make some notes so you remember the size of things like my 1/2 inch hole. That's important because when I make my link, I'm going to need to try to keep that, the right size. So, all right, so here's going to be my link and I'm just going to make, just going to draw it real quick. Here, I'll start with my circles. Lots of different ways to do this. So that's actually going to be a hole. So I made it 0.5, right? And I'll use a construction line to kind of keep track of my distances. So center to center of my little link, I'm gonna make it a little longer. I'm gonna make it 10. So then I need this geometry. So there is copy entities. So sometimes it does that, puts things in here. The entity I want to copy is this thing. And I'm going to do a from to. So from here, I click, now I have it, and to here. So like that, right? So you can, if you think ahead, like maybe I should have done the outside and then copied it, right? So here's going to be my outside of my link. And I'll make it 1. I'll just make it 1. Yeah, looks good. And then I guess I'll demonstrate copy again, won't I? Copy this one from here to here. So that's good. And then I'm just going to draw some lines from here out. Just making my link. Dimensions a little bit in my way. So I drag that out a little bit. Okay. So now I just need to do some trimming. And remember, power trim, this one is by far the best and the easiest. You just draw lines through whatever you want, right? Whatever you want to trim off, you just draw these lines through it. So try to get used to those powerful commands. So notice it sees multiple areas. It sees this area and it sees this area. This area is darker. This area is lighter, but it does see 2 areas. So when you go to extrude, you have to look and see what it's doing and make sure it's doing what you want. It's doing what I want. So that's really good. I'm going to make it 0.2. And I'll just call this connector 1. Should be going to the same folder. Once you set that up, it's automatic. When you're doing this, have your last name in front of that. So that also links all your files together, right? And now I'm going to do one more part. Right, I'm going to do the pin. And in this one, I might have multiple pins because this pin is going to go into a 2-inch block and then also into my link that's 0.2. So this pin is going to be long, but the next pin, if it just put 2 linkages together, would be maybe shorter. So in my assembly, I might need multiple pins and multiple lengths. So I'm going to sketch again. Any plane really works. I try and keep it in position, and a pin is pretty easy to draw. Pretty easy to model. And I'm going to undersize it. So my holes are 0.5, and I'm going to make my pin diameter 0.495. So just 0.005 under, but not the same diameter, right? It does show it as 0.5, but it took my 0.495. So, and I'm going to extrude it. I'll send it all the way into the block 2 inches and then 0.2 for the linkage. Maybe I want a little space. So I'm going to go 2.3 for the length to my pin. That gives me 0.1 space between the block and the pin. So that's kind of, so that's what SolidWorks is all about, is you can really dial in everything exactly as you want it. So I'm going to now save this. And if I was going to name this, as a student, I would need to put my name. And then I might say pin. And then I would, for me, when I do pins or anything like this that could be used over and over, I put down the length. Just so I can look at all the pins and see the lengths and choose the one I want when I go to assemble. So I think I did 2.3 long. All right. So now I have these 3 parts, right? This is going to be annoying. It's bothering me. So there's this one. There's the block and, oh, the chair. I'll close that one. Don't save. And I should have one more. Yeah, there's many here. All right, so pin. Connector, right? And block. This must be just an empty open file, so I'll get rid of it. All right, I want the block. So when you start an assembly, it's nice to use a starting point that is going to be of a fixed object. In other words, an object that you don't really want it to move. This isn't going to move. This is like your ground link in your exercise. Uh, it's nice to have something locked down when you do assemblies because things are going to be moving all over the place on you. So I'm going to open this part and then I'm going to say make assembly from part. So I have the block open. I'm going to go to make assembly from part. What that does when I hit it is it opens a new file. It's called assembly1. You can see that there's a part attached to the cursor and it's also right here chosen. So I could choose a different one if I wanted to, but if I have the right one highlighted, I just click and it'll bring the block in and it grounds that block. In other words, it kind of sets it down and that thing can't move now, right? I can roll around it and look at it, but I can't move it around in my assembly. And I'll show you what I mean by when I bring in another part. As soon as you get an assembly going, you need to rename it. Assembly 1 is not going to work for pack and go. It's not going to work for really anything. So get that name out of there. I name it obviously different than any part file. That's kind of a long assembly name, but it is an assembly. So it has a different extension on it. It has the ASSY, I think, or something like that, but it's not a PRT file, right? It's an assembly file. And you can see I have one part in here, the base. Okay, and now I have some new tabs, and one of them is assembly. So in assembly, we can do a number of things with parts, and here's a bunch of it, right? We'll go through this over time. But right now, all I want you to focus on is making parts and then bringing them into the assembly and then trying to get them to go where you want them to go. So under insert components, I can insert a component. I can make new parts. We'll do that later. I can do a new assembly, which would be then a sub-assembly, right? So we're just going to insert components. So that's just this top button, insert components. If the parts are open in SolidWorks, they will show up here. If the parts are closed, they won't show up and you'll have to browse for them, right? But I'm going to bring in connector 1. So when I do that, I just click it and move my mouse over and you can see, hey, I have connector 1. Now, it's 3-dimensional, so you don't really have control over much space. Like when you place it, I like to actually place it inside of other objects because then I know kind of where it is. But like if you place it out here, it could be, and I just placed it. It could be a long ways away. Like when I rotate it, that happens to be really close, but this could have been a very long ways away. So when you place it, don't do a lot of zooming and crazy, scrolling around. Just do it slowly. And then you can actually I can go like this, and then I can grab this and move it even closer, right? So based on your view, you do have some control over it. And this is not how we position things, but this is how you can get it closer to where you want it, okay? Now, the way we position things, they're called mates, and it's right here. So a mate will take 2 parts and 2 geometries, and it'll mate them. It'll connect them somehow, and there's a lot of different kinds of mates. So for example, I could mate a surface to surface. So I could grab, stuff gets put in there automatically too if you already have it chosen. So I want this empty. I could grab that surface and mate it to this surface. And it does it, right? It pushes it right over there. Now that's just one mate controlling one thing. It's going to stay, those two surfaces are going to stay connected. When I move it, it looks like they're coming apart, but it's not. Those two surfaces are still in line with each other, okay? So this, you have to wrap your head around this, but no matter where I move it, those two surfaces are still in line with each other. In other words, it's controlling one of the three dimensions, okay? So you can always do surface to surface mates, but I wanted a 10th clearance there. You can actually add that. So here I could put in 0.1. So now, as I roll it around, it's actually going to have a gap in there. Do it. Oh, maybe I need to enter that. Here, I'm going to green check mark it. So now it's supposed to have a clearance in there, and it maybe does. It's just really small. You can open mates up, and you can edit those mates. So that opens it back up. Yeah, and it looks like it did not add that in there for me, right? Because it's right here and 0.1. So I don't know why it didn't do that, but I went back in and put it in, and now I can see that, oh yeah, there's clearance there, okay? So you can do surface mates, and then you can put in this offset away from the surface. It's very handy. All right, I'm gonna show you more mates. Notice you just, when you're mating parts, mate just stays open as long as you want it open. So you can do multiple mates. We have a distance mate right here between two surfaces. I'm gonna do another one. I'll show you another one. I'm gonna grab this cylindrical surface and this cylindrical surface, those two surfaces. So it puts them together, and it already chose concentric, but these are the possible mates that I could have used. Could have done parallel, like perpendicular. Perpendicular probably would flip it around. Concentric locks two concentric circles in together. That's really good because they're the same diameter and it just lines them up. So always look and see the mate that are available and see which ones work, right? Whenever I mate something like that, I then take it and try and move it. And I'm like, oh, that works really well. I'm going to keep that mate. If I then couldn't move it the way I wanted to, I would get rid of that mate and then try a different mate, okay? So don't just add mate, add mate, add mate, or it's going to just, the motion won't be there if you want motion. So we want this to move, like this is what we want, right? So, okay. And obviously it'll do it because of the mates, not because there's a pin in there. So I haven't even put the pin in yet, right? But that is the kind of motion I want. It goes all the way around. There are other mates. There's more advanced mates. There's a lot more we can do. We're just going to start slow, okay? Now I am going to bring my last part in, which is my pin right there. I'll place it. So I think it's close. Yeah, it's pretty close. Not bad. I think I'll use the concentric mate again. That surface, a lot of times you got to zoom in and make sure you're getting the surface you want, right? Don't try to mate things from a long ways away. But now, see, I should still have this ability to move it this way. It's holding it concentric, but not in any other direction. So I'm going to add another mate, this surface to that surface. And boom, green check mark. So now it's in position, it goes into the block, and it actually goes to the far edge. So I have that designed pretty well, right? And that, of course, is not going to impede my motion at all. All right, that's the beginning part of assemblies. Yours is a lot like this. You just have a few more parts to bring in and mate up. When you're done, obviously you need to do a save. That saves the assembly, and it always will want to rebuild. So I'll say rebuild. All right, so now it is saved as an assembly. But if you just send me the assembly, I can't open it. I need the parts also, okay? If the parts don't come with the assembly, I can't open it. So the way to do that is what's called pack and go. It's right down here. It's for assemblies. It's going to find the parts in the assembly automatically. There's not a lot you need to do here, but I do want you to save it to a zip file, not to a folder. Folders don't work as well with Blackboard. So go to the zip file. It's going to name it the same as what you had. I'll click in here and scroll over so you can see it. Donaldson, week 5 assembly example, and it gives it a zip. Now, where is it going? It should be going to that same folder. Looks like it is. Desktop, same folder. It's going to flatten it to a single folder, right? But it's going to be a zip file. Save. All right, what's it look like? Oh no, did I really not? Oh no. Shoot. Oh no, I think I paused the screen share. Darn. I think the screen share was paused that whole time. So that's annoying. I think what I can do is walk you back through. So sorry about that, but I am short on time today, so I don't really think I can rebuild this. Let's see here. Yeah, it's not even letting me go back in time. So maybe I can undo it out and show you it backwards. So yeah, that was before the pin went in and the concentric. And I think I had the space put in here. So sorry about that. And I just have brought the pin in here, and then I just need to mate it up with that same mate, that concentric mate. I'm going to undo again. So here's where I brought in this part, right? And I did the surface mate. So you move that around, appears to move it, but it doesn't. So once you get that one surface mate, it'll keep it in line, but it gets far, it can get very far away. So I just keep trying to move it closer. Yeah, and then made up the concentrics. So choose that cylinder there, choose that cylinder there, and that will mate it up. Right? And then every time you mate, just check your motion. All right. And then I brought the pin in. So I'm just kind of going back through it. Sorry about that. But here's the pin. So I click on it. I have it. Again, I try and get it kind of close. And then just set it down with your pick button and then go through your mates again. So the mates I did was this concentric here to here, and it's already chosen. So green check mark that, and then I went this face to this face, and that just lined it up nicely. I think. We'll see. Yep. And it goes through all the way through. Oh, I lost my space mate. So here, this will be a good final example. It's that first one here. That one. So I'm going to edit that. And then I'm going to add back in my 0.1. So yeah, so that actually pulls the pin with it when you go back in time and do that. You got to be careful about that because you can blow your part up. But yeah, so that's good there. All right, and then I think I just showed you pack and go and what that looks like after you do pack and go. What the heck? Why is it says the screen still paused, so I don't know. Yeah, now it says it works. So maybe that was twice that the screen was paused. Wow, sorry about that. I may have to remake this one. I'm going to put this one up for now, and then I'll probably remake one because that's pretty mucked up. But anyway, maybe you got enough to go with out of that first part before it paused. So I'm not sure. Anyway, I will make a second one.